Sample problem 6.3. Calculate the energy in joules of a photon with a wavelength of 5.00 times 10 to the 4 nanometers, which is in the infrared region of the spectrum, and B, a photon with a wavelength of 52 nanometers, which is in the ultraviolet region. And then part C, calculate the kinetic energy of an electron ejected by the photon in part B from the metal with a binding energy of 3.7 electron volts. Okay, 3.7 eV. So let's do A and B. This is very much like sample problem 6.2. The wavelength that is given for the photon in part A is 5.00 times 10 to the 4 nanometers. So let's convert that to meters so that we can do our calculations. 10 to the minus 9 meters is a nanometer. Okay, so that's going to be 5 times 10, that's going to be 5.00 times 10 to the minus 5 meters. So there's part A, we've got the wavelength. So now we can do the energy of that particular photon. hc over lambda. So that would be 6.626 times 10 to the minus 34 joule seconds times 2.9979 times 10 to the 8th meters per second. That's hc, and then we're going to divide that by lambda. 5.00 times 10 to the minus 5 meters. Again, with this type of calculation, the meters are going to cancel, so will the seconds, and you'll have an answer that's in joules. Okay, and that's the question part A. So 5 times 10 to the minus 5 nanometers. So let's go ahead, again, this untrusty calculator. Let's do HC, 6.626 times 2.9979 divided by 5.00. And you get 3.97. Now let's do the powers of 10. 10 to the negative 34 times 10 to the 8th. You add the exponents. So that's 10 to the negative 26. Minus a minus 5. So negative 26 plus a 5 is 21. So 10 to the negative 21. And there's the energy of that particular photon. Okay. Now let's move on to part B. Part B is the same calculation. It's just that we're going to use a 52 nanometer. This would give you quite a burn. This is 52 nanometer photon. Again, 52 nanometers times 10 to the minus 9 meters per 1 nanometer is going to give you 5.2 times 10 to the minus 8 meters. Okay? So there's our wavelength right there. So now the energy of that particular photon is, again, hc over lambda. So 6.626 times 10 to the minus 34 joule seconds times 2.9979 times 10 to the 8th meters per second. And then we're going to divide that by our 52 nanometers, 5.2 times 10 to the minus 8 meters. Okay, so let's try that one. 6.626 times 2.9979 divided by 5.2. 3.82. Times 10. Now let's do our powers of 10. 10 to the negative 34 times 10 to the 8th is 10 to the minus 26. Divided by 10 to the minus 8, we would add 8 to negative 26, and you get negative 18. Okay, so there's the energy of our second photon. It is quite a bit larger, quite a bit greater than the energy of the first photon, right? The first photon is 10 to the minus 21. Now we have a photon that's 10 to the minus 18. That's about 1,000 times more energy. That photon in the UV has 1,000 times the energy of a photon in the infrared. That's a big difference there, right? So now in part C, they say, don't worry about the part A. We just want to worry about part B. it says calculate the kinetic energy of the electron ejected by the photon in part B if the metal has a binding energy of 3.7 electron volts. So they throw in some units here that you maybe have never seen. They're commonly used in physics. Okay, but this is really an issue of the photoelectric effect. The kinetic energy of the ejected photon is equal to the energy of the photon itself. The kinetic energy of the ejected electron, the photoelectron, is equal to the energy of the photon that impinges on the surface minus the work function. That's the binding energy of the surface. Now the binding energy is given in electron volts. It's not given in joules. Okay, so we're going to convert the work function from eV to joules. So let me show you how to do that. This will be an eV to joule conversion. The conversion is that 1 electron volt is 1.602 times 10 to the minus 19 joules. Okay, it's the charge of an electron, essentially. Okay. It's essentially the charge of an electron accelerated through a potential voltage of 1 volt. That would give you 1 eV. So let's do the conversion. It's 3.7 eV. And then it's 1.602 times 10 to the minus 19 joules per 1 eV. Okay. So 3.7 times 1.602. 5.994. I'll round it to 5.99. Okay, so now we have the work function in joules. So we also have the energy of the photon in joules. So that means that the kinetic energy would just be the energy of the photon, which is 3.82 times 10 to the minus 18 joules, minus the work function, 5.99 times 10 to the minus 19 joules. So how do we do this? How do you subtract numbers, add or subtract numbers that have different powers of 10? This is a minus, by the way. Well, one way is just to make the exponents the same instead of having to worry about your calculator. So I could make this one 19 minus 19 just by moving the decimal this way. If I move it this way, that's like multiplying by 10, right? 30.8 becomes 38. That's multiplying by 10. So to undo that change, I divide this by 10, and that makes it 10 to the minus 19. So this would be 38.2 times 10 to the minus 19 joules, minus, I'm going to round this one off to 6.00 times 10 to the minus 19 joules. Okay, so 38.2 minus 6.00 is what? 32.2 times 10 to the minus 19 joules. If we want to get it in scientific notation, we move this back 1 and make this one bigger by 1. So 3.22 times 10 to the minus 18 joules. And there you go. I would say it's probably actually about 3.2. Round it to 2 sig figs. And there you go. So that's the amount of energy that the electron has after it's ejected from the surface, right? So the photon comes in. The photon has energy. It has more energy than the binding energy, than the work function. The work function is holding the electron down. So this energy overcomes the work function, but then there's excess energy. That excess energy goes into kinetic energy. And in fact, if you know the mass of the electron, you could calculate how fast it would move, right? Kinetic energy, 1/2 mu squared. So you could calculate the velocity based on this kinetic energy that we have right here and the mass of an electron, which is 9.11 times 10 to the minus 31 kilograms. You could figure out how fast it's going to move.